This is intermediate algebra, the third part of 6 different parts for the ACT. Intermediate algebra asks questions that you can apply your knowledge, skills, and reasoning ability to solve problems that involve more advanced topics of algebra, like the quadratic formula, radical and rational expressions, inequalities and absolute value equations, sequences, systems of equations, quadratic inequalities, functions, matrices, roots of polynomials, and complex numbers. Let's walk through 3 problems. Again, it'll go from easy to medium to hard. Let's start with the easy problem. Number 32 says the community orchestra will give 18 performances this season. A season ticket costs $60. A single performance ticket costs $5 each. Huang purchased a season ticket. What is the minimum number of performances Huang must attend to save money by buying the season ticket instead of buying single performance tickets for the performances she attends? Well, right off the bat, we know a season ticket costs $60 and it's $5 per ticket otherwise. So if she has $60 and each one would cost $5, the season pass would pay for itself after 12 times of going to the performance. However, their question was, instead of buying single performance, what is the minimum number of performance must attend to save money? Well, she breaks even at 12, so she'll save money on the 13th one. So it'll be 13 would be K, which is my answer. Let's try the next one. This is a medium one. What is the value of h times 1.5 when h of x is equal to negative 4x squared plus 20x plus 32? Not a difficult problem as long as you understand what they're asking. This is a simple function problem. It looks harder than what it is. It's simply saying h of x, this 1.5 has to take the place of that x. That means this 1.5 has to take place of wherever you see x in the equation. So h of 1.5 is equal to minus 4 times 1.5 squared plus 20 times the 1.5 plus 32. Go through and do the math on this one. Multiply it all out and we get minus 9 for this part plus 30 for this part plus the 32. Combine your like terms and you end with h of 1.5 as equal to 53. So my answer in this one would be the letter H. Again, not too bad as long as you understand that you're dealing with a function and h of 1.5 means just plug that into the equation. That's all they're testing on that one. Let's try the third problem. What is the value of y in the solution to the following system of equations? System of equations would be an Algebra 2 problem, maybe a little bit into pre-calc, but this would be more along the lines of a more difficult problem out of the ACT. A couple different ways to do this one. Let's do it by substitution first. First thing I'm going to do is solve for x. I have 2 different equations here, 2 different variables, and with 2 different variables, you got to solve for one of them so that you can set up your equation. This is the easiest one to solve for. I'm going to subtract 2y from both sides. So x is equal to 30 minus 2y. Well, if that's what x is equal to, then this, I can plug into this equation wherever I see x. So 2 times what I just found of 30 minus 2y, which is the x value, plus y plus 3 equals 30. Now it's just a matter of multiplying it all out. Distribute this 2 through, so I get 60 minus 4y plus y plus 3 equals 30, and then combine your like terms. These two combine to give me 63, minus 4y and 1y, there's a 1 there, we just don't necessarily write it, gives me minus 3y is equal to 30 on the right hand side. Now let's solve for y. Get rid of whatever's not attached to y, which is the 63. I need to subtract that off. So minus 63 from both sides gives me minus 3y. Don't forget to carry that minus sign down with it. Is equal to 30 minus 63, which is minus 33. Get y by itself by dividing by minus 3. And whatever you do to one side, you must do to the other. So y is equal to 11. So my solution in this case would be C, 11. Is that the only way? This is called the substitution property for systems of equations. There is another way, and let's look at that one. What if we use the multiplication and then the addition or subtraction property? To do that, you want to combine like terms so you have x and y all on the same side. This 3 goes over, so I'm left with 2x plus y equals 27. Just combining like terms. I can just rewrite this to be x plus 2y equals 30. And then we do the addition or subtraction property. Problem is as it sits, nothing crosses out. So I'm still going to have two variables if I do that. So what I'm going to do is I'm going to multiply this one by 2. So that leaves me with, on top, we're left with a 2x plus y equal to 27. And on the bottom, I'm left with 2x plus 4y. I'm distributing this 2 through, but don't forget to distribute to the right side as well, equals 60. Now, how can we get the x's? I see these are the same, so how do we get the x's to cancel? By subtracting. Because 2x minus 2x is 0x. They cancel each other out. But then you need to do that for everything. Y minus 4y, this is like a 1, gives me minus 3y, 1 minus 4, is equal to 27 minus 60, which is minus 33, and then divide by minus 3. So y is equal to 11. So my answer is C. This would be the addition or subtraction property for solving systems of equations. Either one will work. It depends on what you see first or what you find to be the easiest. That walks through 3 examples of intermediate algebra from easy to medium to hard.